Hello students, good evening. I hope you have seen the video of last class based on differentiation. In that video, I have discussed the definition of differentiation and few formulas. On that context today, I would like to discuss you the continuity. And that is the indispensable part, distinct part of differentiation. And to get the conception on continuity, you have to recall the theorem regarding limit, regarding existence of the limit. What you are taught in class 11, let's see. We are taught that limit extends to C plus fx is equal to extends to C minus fx. In that case, limit exists at x is equal to C. That is the basic definition of the limit we are taught in class 11. Now, how it is related to continuity? See, if I take a smooth curve like this, and this is the coordinate axis, and there is a neighborhood of the point C. You see, this is x is equal to C, and there is a curve y is equal to fx. So this height is fc. The interval, there is the interval. What interval? That is C plus h and C minus h. That means C actually lies between this neighborhood, C plus h and C minus h. And at this point, the height of the curve is C plus h, here is C minus h. Now, if from both sides, these 2 points, it approaches this point, and once if they meet or follow each other, that means the curve will be smooth or continuous. Curve will be smooth or continuous. How it will be possible? That if you get h tends to 0, fc plus h, means this h is being reduced. You see, h is being reduced. That means the point is approaching this point, and here also from left hand side, h is being reduced. That means from this point, this point is approaching this point. This is from right hand side of x is equal to c. This is from left hand side of x is equal to c. So this part is called right hand limit. This part is called left hand limit. So from both sides of this point at this height, these 2 points are approaching along the curve, the point C, fc. This point's coordinate is C, fc. That means h is being reduced, and up to what extent? H tends to 0. Limit h tends to 0, fc minus h. If from both sides they approach and fall on each other, then I can say the curve is smooth or continuous. Or in other way, we can say that limit extends to C plus fx, means right hand limit is equal to extends to C minus fx is equal to fc. That is, limit extends to C fx is equal to fc. Then the function is called continuous at x is equal to c. Then the function, what function? y is equal to, then the function y is equal to fx is called continuous at x is equal to c. This is the basic definition of limit. Just go through and rub it. So this is the basic definition of limit. Sorry, continuity. Okay. So it is related to limit. Why? Because in class 11 we are taught the definition of limit, that if left hand limit is equal to right hand limit, then the limit exists at x is equal to c. Here we have drawn one curve in xy plane, and there is a there is a neighborhood of c, that is c plus h and c minus h, and at x is equal to c the height is fc, at x is equal to c plus h the height is fc plus h, at x is equal to c minus h height is fc minus h. Now if you make h tends to 0 from both sides of this point along this curve, 2 points approaching this point, coming closer to this point, and being close in this way, once they fall on each other, that means there is the smoothness of the curve or continuity of the curve. Okay, that we have got it by graphical representation, and here by mathematical representation, that h tends to 0. See, from right hand part of x is equal to c, h tends to 0, fc plus h. So the point is approaching this point, h tends to 0, fc minus h. From left hand side, the point is approaching this point, is equal to fc. Or we can say x tends to c plus fx is equal to limit x tends to c minus fx is equal to fc, or limit x tends to c fx is equal to fc. Then the function y is equal to fx is called the continuity, okay, at x. So that is the basic definition of continuity. Okay, actually, then the function y is equal to fx is called not continuity. There is one mistake. It's called function y is equal to fx is called continuous at x is equal to c. Okay, and the property is called continuity. So I am running this part, and let's discuss if a function is continuous, then why a function is discontinuous. Let's discuss the reason. Now we will discuss the reason of discontinuity. For what reason a function becomes discontinuous? First of all, see, if you get limit x tends to c plus fx not equal to limit x tends to c minus fx, then function y is equal to fx is discontinuous at x is equal to c. So that is one reason. Means this property we are taught even in the limit chapter. Second reason, see, if fx is not defined at x is equal to c, then y is equal to fx is not continuous at x is equal to c. And the third reason is if limit x tends to c exists but not equal to fc, means left hand limit, right hand limit equal, but that is not equal to fc, then the function y is equal to fx is called discontinuous at x is equal to c. Then this is the three reasons for which a function becomes discontinuous. Now, these discontinuous functions have so many branches. What? A discontinuous function can be split into two types. Okay? It can be split into two types. One is removable discontinuity and another is non-removable discontinuity. Now I will discuss removable discontinuity. Just go through at a glance what is removable discontinuity. We will discuss now. Wait for a while. Now my topic is removable discontinuity. What is called removable discontinuity? Suppose a limit exists, but not equal to it is not equal to the functional value on the point at which the limit exists. Means limit extends to c plus fx is equal to limit extends to c minus fx. That means limit exists. That means limit exists, but limit extends to cfx not equal to x. Then the function y is equal to fx is called removable discontinuity. Is called removable discontinuity. Now, this removable discontinuity also have two types. This removable discontinuity have two types. One is missing point discontinuity. Missing point discontinuity. Another is isolated point discontinuity. One is missing point discontinuity and another is isolated point discontinuity. So removable discontinuity can have two types. One is missing point discontinuity, another is isolated point discontinuity. Now I will discuss about missing point discontinuity and isolated point discontinuity. Okay? So I am going to rub it. Now, what is missing point discontinuity? Suppose let limit extends to c fx exists, but fc is not defined. Then the function y is equal to fx is called missing point discontinuity at x is equal to c. For example, say fx is equal to sin x by x. Examine the continuity at x is equal to 0. See, limit extends to 0 plus sin x by x. It will be what? 1. Limit extends to 0 minus sin x by x. That is also 1. But x0, that is sin 0 by 0, undefined. Therefore, y is equal to sin x by x is a missing point discontinuous function at x is equal to 0. In this case, you see limit exists, but limiting the functional value at the point where limit exists not defined. So this is called missing point discontinuity. Just go through the definition and the example. Go through the definition and the example. Hope you understood. And next, I will skip to isolated point discontinuity. Look at a glance, I will have it in a short while. Okay. Next is isolated point discontinuity. What is isolated point discontinuity? If limit extends to c fx exists and fc is also exists, but limit extends to c fx not equal to fc. This exists, this also exists, but they are not equal. Then the function y is equal to fx, then the function y is equal to fx is missing point discontinuous function at x is equal to c. Let's take the help of an example, because juggling of theory hardly can clear the misconception over this topic. So let us take the help of an example. Say limit extends to 3, x square minus 9 x minus 3 given, and f3 is given 12. So let us examine the continuity at this point. See, limit extends to 3 plus x square minus 9 by x minus 3. That is, limit extends to 3 plus x plus 3 x minus 3 by x minus 3. That part will be dropped. Then I can put 3 only as a side note to write x tends to 3 plus x not equal to 3 plus. Then you will get the value 6. Similarly, limit extends to 3 minus x square minus 9 by x minus 3 also becomes 6. That means limit exists at x is equal to 3, but f3 F3 do not match. But F3 will not match with the left hand limit and right hand limit of the function at x is equal to c, x is equal to 3. So here c limit x tends to 3, x square minus 9 by x minus 3 exists, but at f3 is equal to 12 also exists, but they are not equal. Therefore, the function has isolated point of discontinuity at x is equal to isolated point of discontinuity at x is equal to 3. Just go through at a glance. See what we have taught. Isolated point discontinuity if limit extends to c fx exists and fc also exists, but they are not equal, then the function y is equal to fx is missing point discontinuous function. This missing point discontinuous function at x is equal to c. We have taken one example. C limit x tends to 3 x square minus 9 by x minus 3. That is a limit. You will examine the existence of the limit, and f3 is given 12. See, x tends to 3 plus, you will get 6. Similarly, x tends to 3 minus 6. So limit exists at x is equal to 3, but f3 is equal to 12. So they are not equal. So the function y is equal to fx, that is x square minus 3 by x square minus 9 by x minus 3 has isolated point discontinuity at x is equal to 3. Please note down. I will rub it in short while. Just go through. Go through the definition. Now, non-removable discontinuity, where discontinuity, point of discontinuity cannot be removed, or hardly not possible to make the function continuous. When if limit extends to c plus fx not equal to extends to c minus fx, that is, if limit does not exist and x is equal to c, then the function is called non-removable discontinuity at x is equal to c, or discontinuity of second kind, then you can raise the question, what is called discontinuity of first kind? That is removable discontinuity, which we are taught, that is called discontinuity of first kind. Removable discontinuity, which we are taught few minutes back, that is called removable discontinuity of first kind, and this is the that is the discontinuity of first kind, and this is the discontinuity of second kind, that is called non-removable discontinuity. Now, this non-removable discontinuity have different branches, like finite, oscillatory discontinuity, then infinite discontinuity, etc. Let's discuss different branches of non-removable discontinuity. First of all, one branch is finite discontinuity. Finite discontinuity means say fx is equal to x minus box x. What is called box x? That is called greatest integer function. You are told to examine the discontinuity in integers, in all integers. Examine the discontinuity in all integers. To examine that, I am choosing one arbitrary point. Let one integer value, integer x is equal to c, and I will examine the continuity, discontinuity at this point. Okay, so let us take x tends to c plus, means right hand side of c, fx. What is that? Limit x tends to c plus x minus box x, x minus box x. X tends to c plus means x greater than 0, then what will be box x? C only. So you see x tends to c plus, in place of x I will put c, and box c, if x tends to c plus or x greater than c, box x will be c. So right hand limit will be 0. But in case of left hand limit, x tends to c minus, that is x minus box x. X tends to c minus means x less than c. Means I have to take its previous integer value. C box x will be c minus 1. Put here, in place of x you put c, and here in place of box x c minus 1. Remove the bracket 1. So limit x tends to c plus fx not equal to limit x tends to c minus fx. The function is, in both cases you are getting finite value. So the function is finite discontinuous at x is equal to c, means all integers. So the function is finite discontinuous at x is equal to c, that is at all integers. Just go through at a glance. This is called finite discontinuity. Important part, conceptual part. What is finite discontinuity? You have to come to know. You have come to know, I think. So I'm going to wrap now. Infinite discontinuity. Okay, that is another branch or another part of non-removable discontinuity. Say, let fx is equal to 1 by x. You know hyperbolic function. Examine the continuity at x is equal to 0. So again, like the conception of limit or continuity, limit x tends to 0 plus fx. What is fx? Limit x tends to 0 plus 1 by x. If you put 0 plus means slightly greater than 0, it will become positive infinity. And x tends to 0 minus fx 1 by x, slightly less than 0, negative infinity. And we can say so in both cases we have got infinite value, either positive infinity or negative infinity, and limit does not exist. So therefore the function is infinite discontinuous at x is equal to 0. So this is called infinite discontinuity. Note down, infinite. This is also the part of non-removable discontinuity. So in short while, I'm wrapping now. Oscillatory discontinuity. Suppose fx is equal to sine 1 by x. Fx is equal to sine 1 by x is a function, and you are told to find that, told to examine the continuity, examine the continuity at x is equal to 0. Okay. See, let 1 by x is equal to 2n pi plus theta. Now, if x tends to 0 plus, then theta will be positive infinity. Then in that case, limit theta tends to infinity plus sine 2n pi plus theta. That means sine theta, because you know the periodic function 2 pi, 4 pi, 6 pi, 8 pi is the period of sine. And in case of theta tends to infinity minus, sine 2 pi plus theta will remain sine theta. But you see, this sine theta or this sine theta always lies between +1 to -1. Means this sine 1 by x oscillates between 1 and -1 always. And never converge to a finite limit. So limit does not exist. Therefore, limit does not exist. Limit does not exist, and the function is oscillatory discontinuous function, and the function is oscillatory discontinuous function at x is equal to 0. This is another type of non-removable function, oscillatory discontinuous function. And see, if you put it in mod, it will never satisfy the definition of limit, that is less than epsilon. Okay, limit does not exist. You can prove in this way also, mod sine 1 by x, that is less than epsilon, not less than 1, but not necessarily less than epsilon. It does not satisfy the criteria of the existence of a limit. Now note down, I will rub it in short while. Now, one of the most important part of that non-removable discontinuity is jump discontinuity. You have already come to know that if limit h tends to 0 f c plus h not equal to h tends to 0 f c minus h, that is f c plus 0 not equal to f c minus 0, then the function is discontinuous at x is equal to c. Now we can say if this thing occurs, if f c plus 0 not equal to f c minus 0, then the function is jump discontinuity at x is equal to c, and the difference between fc plus 0 and fc minus 0 is equal to called height of jump discontinuity. Height of jump discontinuity. Let us draw a figure. See, this is x is equal to c. There is a point that is, c plus h, and x is equal to c minus h. See, in this case, if h tends to 0 means fc plus 0, right hand part of 0 minus fc, means this part, this is say fc c plus 0 minus fc, this is fc plus 0 minus fc. This is called right jump, and fc minus fc minus 0, fc minus fc minus 0, that is called left jump. Right jump discontinuity, left jump discontinuity. Now, if you get if this right jump discontinuity and left jump discontinuity becomes same, then the function will be continuous, and if fc plus 0 minus fc and FC minus FC0 are same, then the function is continuous as fx is equal to c and c like this, and the height of jump then the height of jump will be 0. That means if fc plus 0 minus fc and if fc minus 0 becomes same, then the function will become continuous at x is equal to c, and then the jump will be 0. That means if a function is continuous, if a function is continuous at x is equal to c, then at c height of jump will be 0. Means if a function is continuous, then at any point, then on that point the jump is 0. But its reverse is not true. But the reverse is not true. So that is an important part, jump discontinuity. I hope you have understood the graphical representation and theoretical representation of jump discontinuity. Hope you understood what is jump discontinuity. Just look at a glance. I will grab it now. So the different types of non-uniform discontinuity we have discussed. Now, if a function is exponential, okay, in case of exponential function, polynomial, exponential, y is equal to e to the power x. The graph will be like this. Okay, so continuous. Polynomial, quadratic polynomial means parabolic curve, continuous. Then trigonometric function, logarithmic functions, trigonometric and logarithmic functions are example of continuous function, always continuous, smooth. Suppose if f1x and f2x are continuous, then always remember f1x plus f2x, f1x minus f2x, and f1x into f2x are also continuous, but f1x by f2x is continuous if f2x not equal to 0 for all real value of x. Now, if f1x is a continuous function, then k into f1x is also continuous. So this property you just go through at a glance. Okay, in solving problem, this will really help you. So, in case of exponential, polynomial function, trigonometric logarithmic function, the function is continuous, and you have got these properties. Say f1x, f2 is continuous. Then addition, subtraction, and multiplication of those functions are also continuous. But in case of division, it will get stuck in one case. One condition needed, that if f2 is not equal to 0, the division form is also continuous. If a function is continuous function, then the multiple of any constant is also continuous. So this must be remembered by you. Okay. So all these properties will play an important role in solving problems, drawing graphs, okay, and examining continuity differentiability, even on continuity and differentiability, integration and application of calculus are also depending on this. So it's an indispensable part. Try to memorize the topics till now we have gone through. Now next point of discussion is what? The continuity in an interval. That is an important part. Continuity in an interval. I'm writing this part. Now, continuity in an interval. Here, first I will introduce open interval. If a function is continuous in open interval AB, that means it is continuous at every point in the interval AB. So that is the continuity of a function in case of open interval. Say it is like this. In case of closed interval, you see, in case of closed interval, but in case of closed interval, what happens? In case of closed interval, the function is continuous if it is also continuous at property 1. It is also continuous at each and every point in open interval AB. In this open interval AB, at every point it is continuous, so it will be continuous in the closed intervals. Or C, in this closed interval, at this point there is no right hand limit, only left hand limit is required. So in this case, limit extends to b minus fx is equal to fb, and in this case, see, there is no left hand limit, only right hand limit. Okay, a plus, this is b minus, extends to a plus fx is equal to fa. So if all these three conditions satisfy, then a function is continuous in closed interval. So this is the continuity of an interval in an interval of a function, continuity in an interval of a function. So these criteria must be fulfilled. Just go through at a glance. So I'm rubbing now. And next part or last part of continuity, that is intermediate value theorem. Intermediate value theorem. Let's discuss this. What is intermediate value theorem? See, this is the coordinate axis and this is a smooth curve. This is x is equal to a. This is x is equal to b. Y is equal to fx. So from this point you drop a perpendicular. This is fa. This is b. This is fb. You drop a perpendicular. This height is fb. So y is equal to fxba, continuous function in I, where in an interval where a and b are 2 points of I. Then there is a point, see this is fb, say y0. Then there is a point y0 lies between fa and fp. There is a point y0 lies between fa and fp. Then there exists a point, say C. There exists a point C between A and B. Then there exists a point C between A and B, such that FC is equal to y0. This is the intermediate value function. So y is equal to fxb, a continuous function. X is equal to a and x is equal to b is an interval. Now y0 is a point lies between fa and fp. Then there exists a point c for which c lies between a and b, such that fc is equal to y0. So this is called intermediate value theorem. Okay, so theoretical part of continuity is over. Okay, you go through each corner of this theoretical part. If you go through, you will get the the fathom of the subject, the depth of the subject. Okay, continuity is not only left hand limit and right hand limit. There are so many branches which we have discussed today. Let's discuss one sum regarding which can conclude or include all these properties or few properties which we have got today. Let's discuss. See, examine the continuity of mod x by x at x is equal to 0. See, first of all, left hand limit, right hand limit we'll find. Limit x tends to 0 plus mod x by x. We know if x greater than 0, mod x will remain with x. So x tends to 0 plus x by x, that is 1. And limit x tends to 0 minus mod x by x. So limit x tends to 0 minus x less than 0 means mod x will remain with minus x by x minus 1. So automatically we have seen that f0 plus 0 not equal to f0 minus 0, because f0 plus 0, because we are told to examine the continuity at x is equal to 0. So 0 plus 0 means x3 plus 0, x3 minus 0, we are taught 0 plus 0 not equal to f0 minus 0. So obviously it is not continuous. It is a discontinuous function. Now, if you go to the root of the subject, then what kind of discontinuous function it is? Non-removable discontinuous function. Why? Left hand limit not equal to right hand limit. This is non-removable discontinuous function at x is equal to 0. Now, if you want to go to the more critical part of this sum, this is called right jump. This is called jump discontinuity. Why? This is called jump discontinuity. Jump discontinuity at x is equal to 0, because we are already taught if a plus c plus 0 not equal to fc minus 0, then function is jump discontinuous at x is equal to c. So here instead of c we have got 0. 0 plus 0 not equal to 0 minus 0. So it is jump discontinuous at x is equal to c. Now what will be the height of the jump? Height of jump. We got height of the jump theoretically fc plus 0 minus fc minus 0 is height of the jump. 0 plus 0, 0 minus 0, 1. That 0 plus 0 is 1, 0 minus 0 is minus 1, that is 2. So this is height of the jump is 1. Okay, so this is one example we have taught few minutes back. Just go through at a glance. So hope you understood. I'm running now, and another sum or the last sum of today's video I'm showing. That's an important sum, conceptual sum. There is some twist in the sum. So if you go through this sum, you will get more concept on this topic which is taught to you. Grabbing this part now. Wait for a while. See this sum. Here fx is box 6 plus minus box 6. What does box means? Box means greatest integer function. When x not equal to 2, that means in this case x right hand side or right hand limit of 2 and left hand limit of 2 has to be considered, and x is equal to 2, the function value is lambda. Okay, and the function is given continuous. Function is given continuous. So the basic criteria you are already taught, that as the function is continuous at x is equal to 2, that means limit x tends to 2 plus fx is equal to limit x tends to 2 minus fx is equal to f2. So this condition is already accepted. We are taught this thing. Now I will discuss about x tends to 2 plus fx. Means x tends to 2 plus fx, x tends to 2 minus fx, both cases will take the value box 6 plus minus box 6, because x not equal to 2. For x is not equal to 2, the function is defined like that. So fx is box 6 plus minus box 6. Now x tends to 2 plus, it means what? X greater than 2. In that case, box 6 will be 2. Why? Because the numbers are 2.1. X greater than 2 means what? Means x is 2.1, 2.2, 2.3. So its integer part is 2. Box 6 is 2. X greater than 2 means minus 6 less than minus 2. So in that case, box of minus 6 gives previous value, that is minus 3. So limit x tends to 2 plus box 6 plus minus box 6 means limit x tends to 2 plus, this is 2 minus 3, that is minus 1. So this is the right hand limit. What about left hand limit? It must be equal because quantity was given. But still, if you have have the desire to know how we can make them equal and see x less than 2. X tends to 2 minus. It means what? X tends to 2 minus x less than 2. Then box x is 1. X less than 2 means minus x greater than minus 2. So box of minus x greater than minus 2 means box of minus x will be what? Just examine. Here x less than 2 means box x is 1, but minus x is greater than minus 2. Greater than minus 2 means minus box x is minus 2. So limit x tends to 2 minus box x plus minus box x, 1 minus 2 minus 1. So see, put these values in this condition. X tends to 2 plus fx, that is minus 1, minus 1. X tends to 2 minus fx, that is also minus 1. F2 given, that is lambda. So that implies lambda is equal to minus 1. So option A is correct. So the sum which you have got, that is conceptual. It reminds you the mechanism of box function. It gives you the conception of your definition of continuity. It gives you how to make two functions equal, how to make a limit exist, and from that get a constant term lambda. So actually the continuity of the function is described in this sum. So I hope you must be benefited by practicing this type of sum in future. So all the topics, all of continuity is covered up. We could reach all corner of the chapter. We could reach all corner of the chapter. See, in every corner we have touched, and none of the theoretical part is unaware to you right now. If you go through this video properly, see all the theoretical part. So in next class, one step advance will go, that is differentiability, because continuity and differentiability have strong relation, and without examining the differentiability of a function, we should not differentiate it. Okay, so for differentiability, continuity is indispensable, and we have gone through continuity with full concept today. Go through this carefully. Okay, and we'll try to solve more sums like this in future. Okay, and it depends on you. Go through this channel, go through this theoretical part. So next day I will come with the concept of differentiability with more examples. Till then, goodbye. Stay safe, stay home, be happy. Thank you.